Hey everyone, so today we're going to go over how to add complex vectors. Now, for the first example, we're going to have 80 newtons going to the right as our F1, and then we're going to have 120 newtons going diagonally at a 30-degree angle as our F2. Now, what's the resultant sum vector? So before we can do this, actually let's write out what we have. Our F1 is equal to 80 newtons, and our theta is equal to 0 degrees, and then our F2 is equal to 120 newtons, and our theta is equal to 30 degrees. Now, before we can do this, we have to find the x and y components for the 120 newton vector. Okay, so that's our F, that's our Fx, and then that's our Fy. So we know that by Pythagoras theorem, F is equal to the square root of Fx squared plus Fy squared. And then theta is equal to the inverse tangent of Fy over Fx. Fy over Fx. So then we can do F2x is equal to 120 times cos 30, which is equal to 130.92 newtons. 130.92 newtons. And then our F2y is equal to 120 times sine 30. 120 times sine 30, which is equal to 60 newtons. And then we remember that our F1x is equal to 80 newtons, and our F1y is equal to 0 newtons because it's going horizontally. And so now we add the two together. So we add all the x's and all the y's. So our total fx value, so fx sum is equal to 183, I believe. 183.92 newtons. And then our Fy is equal to 60 newtons. And then now we can make a new triangle with that information. So we can go Fx is equal to 180. Let me write that more clearly. Fx is equal to 183.92 newtons. And then our Fy is equal to 60 newtons. And then, so let's make this our A, this our B, and this our C. We can use Pythagoras theorem. So C is equal to the square root of 183.92. 183.92 squared plus 60 squared. And C is equal to 193.46 newtons. So we can leave that there actually. And then our theta is equal to the inverse tangent of 60 over 183.92. Our theta is equal to 18.1 degrees. And so those are our two values. Those are our two final values. So the resultant sum vector will be 193.46 newtons, 18.1 degrees above the horizontal. Now let's try the next problem. Now for the next problem, we have 50 newtons going downwards, and then we have 75 newtons going horizontally, and theta is equal to 40 degrees. 40 degrees. So our F1 is equal to 50 newtons, and theta is equal to 0 degrees, and then our F2 is equal to 75 newtons, and theta is equal to 45 degrees. Now, feel free to pause the video and try this on your own, but when you come back, you'll see that once again we have to find the x and y components of the 75 Newton vector. So when we write it out, we get a little something like this: theta, fx, and fy. We remember that f is equal to the square root of fy squared plus fx squared, and then theta is equal to the inverse tan of fx over fy. And then now we can solve for the components. So f2x is equal to sine 40 times 75, which is equal to 48.21 newtons. Oh, sorry. And then F2y is equal to cos 40 times 75, which is equal to 57.45 newtons. And then we just add that with our initial components. So y was 0, so the F2y will stay the same. And then, y was 50, so we add 50 to 57.45. And then our initial x was 0, so our 48.21 stays the same. So our final vectors, our y will equal 107.45 newtons going downwards, and our x will be 48.21 newtons going to the left. And so now we can make that triangle. We can do 107.45 newtons going downwards, and then 48.21 newtons going to the left, and then that'll give us our resultant sum vector, which will be the hypotenuse. And so we remember Pythagoras' theorem. We can go A, B, and C. So C is equal to the square root of A squared plus B squared. C is equal to the square root of 48.21 squared plus 107.45 squared. C is equal to 117.797 newtons, which is going to round to 117.8 newtons. That's our hypotenuse value. And then theta is equal to the inverse tangent of A over B. Theta is equal to the inverse tangent of 48.21 0.21 over 107.45. Theta is equal to 24.2 degrees. And that's our final answer. So our final vector will be 117.8 newtons, 24.2 degrees from the vertical plane.